Okay, so if we're multiplying and dividing complex numbers, then we are going to use these formulas. Now notice that you're going to have two complex numbers. So we're going to call these Z1 and Z2. Remember before they were just Z. So I'm going to have two R values, I'm going to have two theta values, and then I can use this equation for multiplying. You're going to end up multiplying the R values, but then what are we going to do with the theta values here? Yeah, we're going to end up adding them together. So division, you are going to divide the R values, and then with the theta values, what are we going to do? Can I get some participation in here, please? What are we going to do with the theta values for division? It's still not good. Okay, and then let's read the directions for example 2. So we're going to write these in polar form. We're going to find this product, and we're finding two quotients. So the first one is Z1 over Z2, which we have a formula for, and then I'm going to walk you through the 1 divided by Z1. Okay, now the steps, step 1, it says repeat the same steps as in example 1. So the first thing that we're doing is writing it in polar form. If you look back at the directions for example 1, that's what we did, is we wrote each equation in polar form. And in that step, you are going to find theta 1, theta 2, R1, and R2. And then you're going to plug those into the equations. So if you look at part A for this, okay, to save us some time and so that we could see the relationship, what is special about this Z1 and Z2? Yeah, we just did them, right? Z1 is exactly what we had for what part of example 1? B. And then for Z2, that's from what? Part C. So you don't have to write down this whole step here. If you guys just want to write the same from step 1 and just identify your R, your theta, your R squared, your theta squared. Okay, so all of these, this is from example 1, parts B and C. Okay, so if you just want to write down your R1 and R2, your theta 1 and your theta 2, you can do that. So it's exactly like what we did in example 1. You're going to find your R value using the square root of A squared plus B squared. You're going to find your theta by doing the tangent inverse and finding where that is on your unit circle. Okay, so that's steps 1 and 2. Do you guys have questions on that yet? Okay, so do you guys notice for part B that you had 20 and then pi as your R and your theta? And then for part C, you had 2 and pi over 6 as your theta? Okay, now what we're going to do is plug those in or substitute them into our equations. So this is my polar form. So this is just the answer for part B, and this is the answer for part C. And I'm going to substitute that into my equation. Okay, so my equation is R1 times R2. So my R1 is 20, my R2 is 2. Okay, which is what I found in step 1. Or we can also just look right here. And then my theta value for the first one is pi. For the second, it's pi over 6. We're going to add those together. So we are going to simplify. So 20 times 2 is going to be what? 40. Good. And if we have pi plus pi over 6, what do we have to have for that?
Common denominator.
Okay, common denominator, so it'll be 7 pi over 6. So really, you can just add the denominator to the top. 6 pi plus pi, 7 pi. So then this would be my final answer for the multiplying. Okay, and now we're going to divide. So when we divide, we're going to do Z1 Z1 over Z2, which means I'm going to do R1 divided by R2. So 20 divided by 2 is going to be 10. And then I'm going to subtract these. So just like I needed to get a common denominator to add, I also need one to subtract. So if I do 6 pi minus pi, what do I get? What is, Kylie, what's that going to be? 5 pi over 6. Okay, what questions do you guys have for me on that? Alright, so the next one is 1 divided by z sub 1. Okay, we already have the r value for z sub 1 and the theta value. So for z sub 1, our r sub 1 is what? 20. And our theta sub 1 is pi. Now this is a number here where we can find the r value and the theta value. So if you just have the number 1, okay, remember from the front, step 1, we're going to graph that. So if I'm graphing 1, Olivia, can you tell me where that's going to be on my grid if I just graph 1? That, well, it won't be in a quadrant, it'll be on the line. So this will be 1, 0, right? So, because there's no B. So it'll be right here. Alright, and then I'm going to find what my r value is, and I'm going to find my theta value. So my theta value is tangent of theta equals 0 over 1, which is 0. So my tangent of theta is 0. So in this case, what am I going to use? Am I going to use 0 or am I going to use pi? Where's tangent 0? So what's my theta going to be? 0.
So 1 is going to be r and theta is going to be 0.
Yeah. Okay, and then so to find your r value, you would do r equals the square root of a squared plus b squared. So 1 squared is 1, 0 squared is 0. The square root of 1 is going to be 1. Okay, so we can think of our r value as 1 and our theta value is 0. Okay? And that's just for the number 1. So then we can divide like normal. So if I have a 1 on the top, what's the r value? What's the r value of 1? 1. So it's still just going to be 1 over the r value of z sub 1, which is 20. Now here, I just put negative cosine, okay, because for my theta sub 1, I have pi, and what was my other theta? 0. So what's 0 minus pi? Negative pi. And guess what? If that's always 0, it's always going to be the opposite. Yeah.
So why do you have to like take these steps? Why can't you just do 1 over z1 and then multiply by the conjugate?
Don't multiply by the conjugate, but it'll be of the opposite. And you do. That is what you're going to do. But if you don't know where it comes from, then people start to get confused about why I do this and why I do this. Okay, so the reason why you have the 1 on top is because the r value of 1 is 1. So that's why I put that as a side note here. So for 1, the r value is 1, and the theta value is 0. And because of that, we're able to go straight to this step.
Did I like miss a formula or something?
Miss a formula for this?
Oh, okay. So like, it's like you're treating.
It's still the division
You're
formula.
treating 1 like its own z.
Yes, exactly.
Okay.
So if you want, you could think of this as Z1 and this is Z2,
Yeah.
and that would be Now you can see that I have this, but then I jumped down to this as my final answer. Right? Aditi, why would I change this to this in this step? Cosine of negative pi to cosine of pi. Okay, good. And then Megan, what else did I change? For what? For what function? For the sine, right? So the sine of negative pi is equal to what? So if it's cosine, it's even, right? And whatever is the cosine of the negative is cosine of the positive. But sine is odd. So what happens to that negative? Yeah, it's going to go in front. So see how this negative went out in front? And then my sine is still going to be positive. Okay, so you do have to simplify using your even and odd properties. So yeah, you don't have to do this out every time for the one. You needed to see where it came from so you understood why we're doing those steps. So yeah, make sure you use your even and your odd properties. Okay, and let's go to B if you haven't already. Yeah.
For that one, why can't we just do 1 over like the entire z thing? Like 1 over 20 times cosine pi plus I sine of pi.
Well, because then it would be the reciprocal. And then you wouldn't have the same value. Like if you do the 1 over this.
What's exactly happening when we multiply two of those things?
When you're multiplying the two of them together.
Yeah, like if we multiply z1 times z2, what is exactly happening there?
Exactly what we said. So they're just being multiplied together. So just like if you're multiplying 4 times 6, right? When you're multiplying 4 times 6, you're multiplying the number 6 4 times. It's the
If I
same
multiply,
thing.
Like 1 plus I times 1 plus I can do that same thing but with polar.
Yes.
Okay.
Yes, exactly. Exactly. Yeah, Abby.
Are they ever gonna give you like use like pi over z1 or something like that?
Pi over. No,
Like
it's a.
instead of 1?
The directions are going to be the same
Okay.
as 1 over z sub 1.
Okay.
Okay, so for B, the first step is going to be the same, but when we try to find theta, it's a little bit different because when you're setting up your theta for 4 over 3, I can't find that on the unit circle. What do I have to do? Yep, I'm going to have to take